Hello class, in this video I'll be showing you how to find the maximum value of a function given a list of constraints. Let's begin. So sketch the feasible region for the following set of constraints and then find the maximum value of the objective function z is equal to 15x plus 15y. Okay, so we're given a set of 5 constraints and I'm going to go ahead and graph the bottom 2 first. So we have x is greater than or equal to 0. And that is a vertical line that travels through the y-axis. And we're going to shade to the right of this line because we want values of x that are greater than or equal to 0. Next is y is greater than or equal to 0. So that is a horizontal line that passes through the x-axis. And we're going to shade above this line because we want values of y that are greater than or equal to 0. So now on to the other 3 constraints. So if we solve the top inequality for y, you'll have y is greater than or equal to negative 7/9 x plus 14. So that implies that the y-intercept is 0, 14. And I'm going to graph the boundary line now. So here is 0, 10. 0, 14 will be right here. Traveling down 7 to the right 9 will be the coordinate 18, 0. And I'm going to connect those 2 points now. Okay. Next is equation or inequality number 2. I'm going to skip that one for right now and move on to inequality number 3. So if we solve this inequality for y, that'll be y is less than or equal to negative x plus 45, which implies that the x-intercept is 45, 0, and the y-intercept is 0, 45. And I'm going to go ahead and graph the boundary line using the x and y intercepts. So here's 40. So 45 is right here. And along the x-axis, here's 40. 45 is right here. And I'm going to connect those 2 points with a nice straight line. All right, so looking at where we have to shade, in the first constraint, we want to shade above the pink line, and with the third constraint, we want to shade below the blue line. So below the blue line and above the pink line. So the feasible region is going to be somewhere in here. Okay, now for the second constraint. Solving this inequality for y will be y is less than or equal to 18/11 x minus 85/11. Okay, so if we take a look at the y-intercept is negative, and so we're not going to use the y-intercept to sketch the boundary line. If we want to use the x-intercept, we also run into a problem because the x-intercept is 85/18, which is not a clean decimal to plot. So we need to come up with another method to graph this boundary line. So what I'm going to do is I'm going to find the following. I want to find 2 coordinates on the boundary line, (18x minus 11y is equal to 85, using the other two constraints. So what that means is that I want to solve two systems of equations. The first one is going to be the following. 7x plus 9y is equal to 126, and 18x minus 11y is equal to 85. And the solution to that system is 9, 7. The second inequality we are going to solve is x plus y is equal to 45, and 18x minus 11y is equal to 85. And that solution is 20, 25. Okay, so what are we going to do with this information? Well, notice this ordered pair, 9, 7, is a solution to this equation that I just highlighted in green. It is also a solution to that pink equation that I just highlighted in green. So I'm going to place a point at the coordinate 9, 7. So here's 9, 7, which is right about here. And notice that that green dot lies on the pink line. For the second equation, or for the second system, the solution is 20, 25. So I am going to place a coordinate at the point 20, 25. So here's 20, all the way to 25, that's going to be right here. And notice that that point lies on the blue line, because we solved this system right here, which involved the equation in blue. Now I'm going to draw a straight line between those 2 points. Okay, and since we have y is less than or equal to, we're going to shade below this line, that's in green, which makes the solution set, or the feasible region, this area right here. And the 4 corners I'm drawing in black right now. Those 4 corners, one or more, will produce the maximum value of z. So the corners are as follows. (9, 7, 20, 25, 18, 0, and 45, 0. And we know that z is equal to 15x plus 15y. So we're going to substitute the ordered pairs individually into z to see which one provides the maximum value of z. So it looks like there are two ordered pairs that produce a maximum value of z. So we can conclude that z will be a maximum value of 675 at the ordered pairs 20, 25, and 45, 0. And we are done.